Welcome everyone to this tutorial on using CLC Genomics Workbench for SARS-CoV-2 bioinformatics for public health. In this tutorial, we are going to focus on SARS-CoV-2 sequencing using the Arctic Amplicon protocol and Illumina DNAflex library prep. There are other ways of sequencing SARS-CoV-2, but these are the range of tools and expertise that most public health labs have to perform SARS-CoV-2 sequencing. And before we get into this analysis, right now up on the screen I have the full workflow, which I have to admit, when I started using CLC a while ago, I find these workflows to be quite intimidating. It looks like there's a lot going on, a lot of directions of data. So what I'd like to do in this first video is just talk about where we want to get to and put this workflow aside. And where we want to get to is being able to take your FASTQ files from Illumina and do something that we're all familiar with. Import the data into CLC Genomics Workbench, go through what's similar to a FastQC analysis to QC your reads and look at the quality, the GC content, the read lengths, the quality scores. And then from this data, using reference mapping, we want to generate consensus sequences. And here you could see this is from some data that I've downloaded from the short sequence read archive for SARS-CoV-2. And we want to generate consensus sequences so that we can share these consensus sequences with repositories like GISAID or GenBank, so that public health scientists can perform surveillance and look at how the virus is moving around a population. So not only do we want to generate that consensus sequence, but we also want to, use this analysis for variant calling. And for the variant calling, we also need to know, how good our data is with respect to coverages, average coverage, maximum coverage, the fraction of the reference that was covered by actual reads at a certain depth. And in the end, the overall picture of what we're going to generate from this workflow is something like this genome view. And so this was an analysis done with 12 specimens. And this genome view allows you to look at the coverage for each one of your specimens, the raw read mapping for each of these specimens against the genome, so you could get a visual measure of how good or bad the data is. And then also variant calls. And these variant calls can be used for further phylogenetic analysis, but in these views here for the genome view, what you could actually do is say, look at your first specimen, get a list of variant calls, and then visually confirm the variant call and see if that variant shared amongst other specimens, and then the alignment data against the reference that's used in support of these different variant calls. So this is a really, really nice system for SARS-CoV-2 bioinformatics, from the QC to the overall mapping, the variant calls, and then also with audit trails, because any of these analyses, if you go in, you could look at histories and have your audit trails for every step that was done along the way in bioinformatics. And you don't have to have any experience with Linux, no experience with command line. It's all, with a certain amount of upfront effort in understanding the package, it's available to most public health scientists that are in microbiology. So what we'll do for this tutorial series is we are going to build this workflow step by step that you see here, so that it is a lot less confusing than it looks right now. And for each step, we'll discuss the outputs and how they connect to the next modules. We'll discuss a little bit about the configuration, the inputs, the references, and in the end, you'll have your own developed workflow that you can use to generate your own results for SARS-CoV-2 sequencing.